Welcome back, guys. Today we test the ultralight Warren 2.4 X-beam against a carbon fiber tube with increasing static load while measuring the deflection. The test takes not into account gravity and twisting forces. The test will be performed at room temperature and at 80 degrees Celsius. A printed box mounted onto the carriage allows for lead weights to be loaded. Each weighs 500 grams and we test up to a total of 5 kilograms. The setup consists out of a MGN9 rail mounted onto the X-beam as the design allows for it. This means 4 screws for the carbon fiber tube and 20 screws for our aluminium X-beam. Yes, the 20 screws improve stiffness and would probably also be better for the carbon fiber tube. But I did not want to mod the carbon fiber tube and will test it as it came. So take the results with a grain of salt. There are different carbon fiber tube designs and also the carbon fiber composite and waving pattern can be different. Disclaimer: this test is not the be-all and end-all. Depending on your printhead, the load might also not be applied perpendicular to the carriage. It is also possible that the results are not absolute. Even though we produce and sell this X-beam, I tried to make the test fair. I am not an engineer, so please correct me in the comments if I draw some wrong conclusions from these observations. If your printhead weighs 500 grams, each lead weight added resembles roughly an acceleration of 10 km per second squared. If your tool head weighs 250 grams, you can double the acceleration to get the same deflection. In this chart you see that the carbon fiber tube wins this round clearly by not deflecting as much as our aluminium X-beam. Honestly, I was a bit disappointed by this result. But now let's continue to the elevated temperature test. The whole test takes place on a flat granite slab which is located on top of a warming tray. I turned on the heat and waited until it reached roughly 80 degrees Celsius. To resemble somewhat of an enclosed printer and keep the air around the test subjects warm, I built the enclosure out of balsa wood. As you see, this carbon fiber tube seems to drift in a high temperature environment under load. It deflects way more than in the previous room temperature test. Looks like the carbon fiber tube did not like this test, it sustained permanent deformation. I guess the problem on this particular carbon fiber tube is the resin. It seems to soften under these temperatures. Maybe a carbon fiber or resin expert can explain this behavior in the comments. After the test at around 80 degrees Celsius, I was happy to see that our X-beam performed almost the same as on the room temperature test. There is one more thing you should know if you get an aluminium X-beam. It deforms when heated, which means that you have to heat soak your printer before performing the bed leveling. You can see that already a bit cooler air has an obvious impact on it. The same thing is true for a carbon fiber tube, but it deforms in the opposite direction when heated. Let's look at the weight, including the hardware, to assemble these two options. As you see, they have essentially the same weight. My honest conclusion is that this carbon fiber tube is probably better if you don't print at elevated chamber temperatures. It is also a lot cheaper than our aluminium X-beam. As stated before, there are many different options of carbon fiber tubes out there. Maybe there is one who can handle elevated temperatures better. If you want to print at elevated temperatures with the lightweight option while having peace of mind that it does not deform permanently, you can surely consider our X-beam. And just for reference, here a demonstration how much a rail deforms without the support of a carbon fiber tube or aluminium X-beam. Cool that you made it this far. In contrast to the ultralight Warren 0.1 X-beam, I will sell the 2.4 version with a profit. If you decide to order one, you support me and my future Granite CNC project, which will be covered on this channel. You have also the possibility to support me on Patreon, where I post short videos and pictures about the progress. Thank you for watching, until the next time, bye!